Good day, fellow. We are going to continue with some theorem, but today we are going to do theorem 2, which states an angle which an arc subtends its center is twice the angle which same arc subtends at circumference. See, then they are going to give you a diagram which is like something like this, say we have O, A, B together with C there. Then our requirement is that they gave us A, B, C with center O. A, B, C are your points on the circumference. Then now we must prove that AOB, angle AOB, this one is twice A, is twice that one. ACB. We must prove that this one is twice this one. See? Then how are we going to do that? So simple. Let us construct. Okay. We are going to join CO to give us, or let's say to produce somehow, let's say D, somewhere there we have D. See, then at this point you can then now label 1, 2 this side, label 1, 2. Check. We have two diagrams. If you can view clearly, we are going to have something like this together with something like this. See, it's O1, O2, OO, C1 this side, C2 that side, A, there is B. Then how are we going to proceed now? We are going to say, from grade 10s, you did these things, that angle O1, our angle O1 on this one is going to be equals to angle A plus angle C1. Do you still remember this thing from grade 10? An exterior angle. You see, O1 equals to this one and this one. O1, this one, equal to this and this. See? Then we are going to reason by say exterior angle of triangle. See? It's also true on this side. This angle, which is O2, is going to be equal to C as well as B. See? Then our angle O2 will be equals to angle B together with angle C2, exterior angle of triangle. We are not done yet. Check. Do you also still remember, if we have, let's say, a triangle like this, having this side equal to this side, which two angles are going to be equal there? Clearly, this one and this one. Check. On our diagram, we have two triangles. We have this triangle. Do you see this triangle? Together with this triangle. But for now, let us only focus on this one. Do you see the radius O? The radius OC will always be equal to the radius OA. In fact, the radius or the radii of a circle, they will always be equal, all of them. Then at this point, we can clearly say now our angle A will be equals to angle C1. We get a situation which is like this. If I were to split this triangle, going to be C1 there with A, O. I have two radii, you see. Then we are going to say A is equal to C1. Then your reason is OA, which is equal OA is equal to OC. OC, those are your radii. You see, those are your what? Are your radii. Let us also do the same on this triangle. Another triangle somewhere there. Let me write it here. We also have this triangle, which is O somewhere there, C there with B. This radius is equal to this one, you see. Then C2 will be equals to angle B. We do the same. Angle B will be equals to angle C2. Now we have two radii, which is OC, OC with OB. OB, those are your radii. Now at this point, we can then add these two equations by saying now we have equation O1 plus O2, which is equals to A plus angle C1 plus angle B plus angle C2. You see? Let us now replace A and B with what? With C1 and C2. Where you see A, you place C. Where you see your A, you place C1. Where you see B, you place C2. Then it's going to be O1, O2. See? I don't have much of space. But what I'm going to do, I'm going to erase. Let me erase somewhere. Erase somewhere here. It's just a continuation. Somewhere here. See? Let me continue. By saying now, I can add these two. I can add these two. By saying 2 angle C1 together with 2 angle C2. Let us factor out 2 and remain with C2. Close the bracket. O1 angle O2. See? Not that difficult. At this point, you can clearly see if I add O1 together with O2, I get AOB. You see, if I add these two, I get AOB. And write 2. If I add C1 and C2, I get ACB. ACB. Then this is our proof. You see, this is how we prove the theorem 2. Now let us do some application, a simpler one. A simpler one. A simpler one. Or before I can even go there, you must bear in mind that theorem 2 has two variations. It can appear like this, like this, or like this, or like this. Then let us try to identify the angle at center is this one. The angle at circumference will be this one. When it is like this, the angle at center is this one. You see, the angle at center is twice the angle at circumference. Same, the angle at center is twice that one. For this one, it's going to be this side. The angle at center is twice the angle at circumference. Either this one or this one or this one. They are the same. You see? Then now, let's see if I have a diagram like this now. Then they say to me, this one is 30 degrees. Let's say it's A. Let's say we have B, we have C, O. Then the question says to us, find BOC. Find BOC. How are you going to determine BOC? So simple. You must do it like this. So the BOC is equals to 2 BAC. See, your reason is angle at center 2 times angle at circumference. See, then we know that our BAC is 30 degrees. Then we write BOC. Then we take our calculator and multiply, get 60. Then this angle is going to be 60 degrees. You see, it wasn't that difficult. I thank you.